Now, as we have seen, there are a set of registers in the CPU. Now we need to understand the register organization. So within the processor, we have a set of registers, and where these registers are present in the memory hierarchy. So if we can see here, these registers are present above the main memory and the cache memory. So as the size gets smaller and smaller, the cost of the component gets higher. So the registers are costly, and hence there are minimum amount of registers can be used in the processor. Now these registers, they can perform two roles: user visible registers and the control and status registers. So actually it is not exactly these two kinds of categories, but for our understanding we can categorize it in these two ways, so that it will be easier for us to understand how these registers are helpful inside the processor. So the user visible registers are such that they can be referenced by the use of the machine language, and this control and status registers are helpful to control the operation of the processor. So now we'll see about this user visible registers. So again, this user visible registers can be categorized into four categories: general purpose registers, data registers, address registers, and condition codes. So this general purpose registers, it can be assigned for a variety of functions by the programmer. So the advantage of this general purpose register is that it is very flexible. So any register can be used for any purpose, and it can usually, this general purpose register contains the operand for any opcode. So we know the opcode is that any operation or the action that has to be performed by the processor. So the operand for any operation can be contained, can be put in a general purpose register, or sometimes it can be restricted in use. So specifically it can be used only for a floating point operation, or only for stack operations, or it can be used only for the for addressing the functions, like what we have discussed in the addressing modes, for indirect addressing or displacement addressing. So like that, we can have the general purpose addressed either in a specialized way, or for a to use for any purpose. And this general purpose registers can also be used as the data registers or the address registers. So this data registers, it can be used only to hold the data. So this will not be used for calculation of the operand address. That is what we have discussed in addressing mode as effective address or the actual address. So here it can hold only the data and not the address. And if it is going to be used as the address register, then it may be used for any particular addressing mode, or it can be used in a general purpose way also. And while discussing these general purpose registers, there are few design issues present in the thing. So what are the design issues available? Whether these general purpose registers has to be completely used as general purpose, or we need to specialize them, or for example for any specific purpose. So what is the difference? If this general purpose registers are going to be purely general purpose, then it has more flexibility. The programmer has so many options, and the programmer can use any register for storing any data or operand, anything. Okay, but when it becomes specialized, and this will be implicitly represented by in the opcode itself, that only this particular register has to be searched for finding a particular opcode for a particular operand. So but though it is helpful while searching for a particular register, the flexibility becomes less. The programmer cannot use this particular register for various purpose. Only for that particular specialized purpose it can be used. So this is one issue. And the other issue is that how many general purpose registers can be used. So basically between 8 and 32 is the optimum number of registers. So as we see, the registers are costly, and we cannot have more number of registers. So the optimum number of registers is between 8 to 32. So when there are fewer registers, then we need to go for more number of memory references, and when we have more registers, it will reduce the memory references. We need not every time go and check the main memory. So the registers will be helpful in that case. And the third issue is that how long this register should be, or the length of the register. The length of the register should be at least long enough to hold the largest address. So in the main memory, the address, it starts for example, if it starts from 0, 1, 2 and it goes on till the nth memory location, the largest address has to be the register should be long enough so that it will be able to hold the largest address of the main memory, and also it should be able to hold the values of most of the data types. So we have different data types, and all these operands are different. So all these data has to be the register should be able to accommodate any of these data type. So these are the design issues that are available in the while we are considering the general purpose registers. And finally, the last one is the condition code registers. So what this condition codes is, it can also be referred as flags. So these are bits, okay, it's set by the processor hardware as a result of the operations. For example, let us take an arithmetic operation or any logical operation. So the result of that operation, it may be a positive value or a negative value or a zero value or a overflow. So this positive, negative, this result, it is going to be set as a flag, and that is called as this condition code. So now during any conditional branch operations, this condition codes are tested. And for example, if you can see here some conditions like that. So if the value is 0, then jump. So in that case, we will be reading this condition code, and based on the value, the decision will be made. And one important thing that we have to remember is that these condition codes cannot be altered by the programmer. So it will be set by the programs, and it cannot be altered by the programmer. Okay, so these are the registers available as general purpose registers, that is the user visible registers.